All right, assalamu alaikum. So this is Geometry 6.03. All right. So in this lesson, we're going to be talking about density. So what is density? Well, density is a ratio of mass to volume. All right. So what does that mean? It basically means that if you have two objects, all right, each of those objects, all right, takes up a certain amount of space. For example, let's suppose we have a brick. Let's suppose we have two bricks. All right, so we have this brick on the left over here, and then we have a brick on the right. So the brick on the on the left, all right, let's say this is a regular brick. All right, so just made up of, clay that's been baked together. So this takes up a certain amount of space, right? It takes up a certain amount of volume, and it has a certain mass. If you put it on a, some kind of a scale, it's going to tell you that this has, 1,000 grams, 2,000 grams, whatever it is, it has a certain amount of mass. So it takes up a certain amount of space, and it has a certain amount of mass. Now let's say the brick on the right over here is, basically the same size, right? So the volume, right, like if you measure the sides, 2 inches by 4 inches, whatever it is basically the same size as this one on the left. But the difference is that this brick over here on the right is made up of styrofoam, right? So obviously this brick over here is going to weigh a lot less. It's going to have less mass, right? So the two bricks, they have the same volume. They take up the same amount of space, but the one on the left has a lot more mass than the one on the right. So what does this tell us about density? Well, what it tells us is that this one on the left has a lot more stuff packed into the same amount of space. Both of them take up the same amount of space, but the one on the left is a lot heavier. It has a lot more stuff packed into that space. This one over here on the right, made of styrofoam, is very light. It has almost nothing there. It's very, very light. So we would say that the brick on the left has a higher density than the brick on the right. So let's suppose that the brick on the left, has, takes up a volume of, let's say, 20 cubic centimeters, right? So you can use other, units of volume as well, but let's say this one over here takes up 20 cubic centimeters. That's the amount of space that it takes up, right? Now this one over here on the right also takes up the same amount of space, right? Remember we said they have the same volume. So this one is also 20 cubic centimeters, right? But the difference is in terms of their mass. So this one over here, let's say it takes up, has a mass of 1,000 grams, right? But this one over here is very light, right? It has the same amount of space, but this one is very light. Let's say it takes up only, let's say, 60 grams. So this one is very, very light. You can see that in the same amount of space, this one on the left has a lot more stuff packed into this 20 centimeters than this one does. This one only has 60 grams worth of stuff packed into 20 centimeters cubed. So let's figure out what is the density of each one of these bricks. All right, so how do we find density? So we find density by taking the amount of stuff divided by the space that it takes up. So the formula for this one is density equals mass divided by volume. All right, so this formula over here, you have to have it, memorized. There should be no looking up or anything like that. You just have to memorize it and know this one. So density is the mass, which is these ones down here, divided by the volume, which is this one up here. Right? So what is, mass? 1,000 divided by the volume 20. This one over here is going to have a density of 50 grams per centimeters cubed. So notice that the units of the mass goes on top, divided by the units of the volume, which goes on the bottom. So this one has a density of about 50. So this one you can see is like really, really packed. All right. This one over here is 60 grams divided by 20 centimeters cubed. So that's only about 3. That's only 3 grams per centimeter cubed. So this one over here, the regular brick, This one has a very high density. This one over here, the brick made of styrofoam, has a very low density. All right, let's take a look at this problem over here. Now, before we talked about density, right? We talked about density equals mass divided by volume, right? The amount of stuff, right? And this is the amount of space. All right, so let's take a look at this problem over here. So it says an average classroom measures 20 feet by 30 feet by 10 feet. If the maximum capacity of a room this size is 45 students, what is the density of this classroom? So notice in this one, right, we don't have, mass divided by volume, right? So I have number of students, and using these measurements, I can find the volume, but, I don't have mass, right? So this is kind of a similar kind of idea. This is not strictly speaking, density in terms of the, scientifically necessarily, but this is, another kind of density. Here we could think of, not the amount of mass per space, but the amount of students per space. So it's kind of a similar kind of idea, right? So instead of mass, you got to figure out, what am I going to use instead of mass? Well, which one is like the amount of stuff or the amount of whatever in that space? It's the number of students, 45 students. So instead of mass, on top, I'm going to put 45 students. Right? So 45 students. Now, the amount of space, in this case, is a volume. 20 feet by 30 feet by 10 feet. Right? So that's the dimensions of the classroom. So how do we find the volume of the classroom using that? Well, let's take a look at what a classroom would look like. A classroom looks like this. Right? It's kind of a rectangular prism. So maybe one side is 20 feet, another side is 30 feet, the side is 10 feet. So how do we find the volume? I multiply length times width times height. So that equals 600, 6,000. So that's 6,000 feet cubed. Right? So this right over here, I go ahead and I divide these two. 45 students divided by 6,000 feet cubed. So I'm going to go over here to my scientific calculator and we're going to put it in, right? So on the top we have 45 students divided by 6,000 cubic feet. So this is our density, right? So this is the density, 0.0075. So I'm going to go back over here and I'm going to write that down. .0075. Now, what are going to be the units of this number? Well, I go back over here and I take a look at the units. So it's going to be students per cubic foot. So I'm going to write it like this: students per cubic foot. So there's 0.0075 students per cubic foot. So here, we're using the same basic formula for density, something like the amount of stuff per the amount of space. So those are not always mass and volume necessarily, but it's the same kind of idea. The amount of stuff divided by the amount of space. So you got to figure out in each problem what counts as the amount of stuff and what counts as the amount of space. All right, so now let's take a look at another problem. So again, I'm going to write down my formula, right? So we have to have this memorized. No one should be looking this up or anything, right? So this should be just memorized. Density equals mass divided by volume, or the amount of stuff divided by the amount of space. All right, so if the maximum density of a restaurant is 0.075 people per cubic foot, and the volume is 2,000 cubic feet, what is the maximum number of people that can occupy the restaurant at any given time? So let's take a look at this question. So in this case, we're not trying to find the density. See, they give us the density. You notice over here, they're giving us the density. So what are we trying to figure out? We're trying to figure out the maximum number of people that can occupy the restaurant. All right, so we have to figure out, what over here is going to be kind of the mass or the amount of stuff, and what is going to be the amount of space. All right. So we have two numbers that they're giving, and there's one number that we're trying to figure out. All right. So we have 0.075 people per cubic foot. So which one of these three things is that? Well, that's the density, because that tells you people per cubic foot. That's the amount of stuff per volume. So that's going to go over here. That's going to be, what D is. So I'm going to rewrite, and I'm going to plug in some of these numbers. Right? So I'm going to rewrite this. 0.075 equals, right? So what is going to be the amount of stuff here? Is it going to be this? The volume is 2,000 cubic feet? No. Number of people, that could be the amount of stuff, right? The number of people, that could be the amount of stuff. So we don't, this question is telling us that we don't know the number of people. So I'm going to put an X there. And what is going to be the volume? 2,000 cubic feet. So we're trying to find the number of people. So what does that mean? This is an algebra equation. We have to solve for X. All right, so how do we solve for X? Well, on the right side, I have X over here, but I have divided by 2,000. All right, so I have divided by 2,000. So how do I get rid of this divided by 2,000? I do the opposite. I multiply both sides by 2,000. So it's going to look like this. Right? So on the right side, the 2,000 is going to cancel out. And on the left, I'm going to have 2,000 times 0.075. So let's go ahead and put this into the calculator. So I have 2,000 times 0.075. So that's going to be 150. So go back here, that means that 150 people can fit in this restaurant. So in this case, this one is a little bit different. We're not trying to find density, we're trying to find something else. Right? In this formula, we plug in the things that we have. Right? You look at at your problem, you plug in all the things that you can plug in, and then you got to solve for whatever is left. All right, let's do one more problem. So this one over here says the density of a fish tank. All right, so first of all, I'm going to write down my formula. Density equals mass, or amount of stuff, divided by the amount of space. All right, so the density is 0.5 fish per cubic foot. So that's kind of a hint. Whenever you see that, that's a hint as to what the units should be. Right? So the density is 0.5 fish per cubic foot, and the volume is 12 cubic feet. What is the number of fish in the tank? All right, so let's try to plug in what we can. All right, so 0.5 fish per cubic foot. So where does that go? Well, whenever you see like something per something, that's going to count as D, density. So I'm going to write that in, 0.5, right? Fish per cubic foot equals, right? Equals stuff per volume. All right, so what else do we have? The volume of the tank is 12 cubic feet. So where does that go? Is that stuff or is that volume? So that's volume, right? That's the amount of space. So I'm going to put in 12. And it's asking what is the number of fish. So that must be the one on the top. It's asking us what is that. So that's the unknown. That's the variable that we got to solve for. So how do we solve for X here? This is X divided by 12. So I want to get rid of this divided by 12. So I do the opposite. I multiply both sides by 12. So I go like this. 12 times 0.5 equals X. And so you see now the 12 is gone on the right. So X is equal to 12 times 0.5. So what is 12 times 0.5? 6. So it says that in this tank, there are going to be 6 fish.